Good day, ladies and gentlemen. The title of my presentation is A Critical Analysis of Water Resource in South Africa's Thermoelectric Power Sector. My name is Elisha Didam Markus from the Department of Electrical, Electronic and Computer Engineering, Central University of Technology, Free State in South Africa. The sequence of my presentation is introduction. I'll talk about Eskom power stations, power generation dependence on fresh water, current water conservation strategies. I'll talk about innovative technologies for thermoelectric power plant cooling, recommendations, and then I'll conclude. Introduction. South Africa is a water-scarce country with irregular rainfall patterns. Current usage is estimated to be between 15 and 16 billion cubic meters per annum. Eskom operates 29 power stations with a total nominal capacity of 44,000 megawatts, comprising over 3,600 megawatts of coal-fired stations, over 1,800 megawatts of nuclear power, over 2,700 megawatts of gas, 600 megawatts of hydro stations, and 1,400 megawatts from pumped storage stations. Also, the recently commissioned Siri wind farm provides about 100 megawatts. If you look at the figure, we'll see that Eskom power stations, the coal-fired generating stations is mostly used across the country when compared to all the other power generating stations. And if you look at in terms of installed capacity, the coal power stations have the highest installed capacity. In terms of the history of energy consumption, we also see that the coal occupies a very large percentage. We also realize that from the chart, we can see that in terms of water use in South Africa, irrigation consumes about 60%, while power generation consumes 2%. This 2% looks a bit small, but when you look at the number of stations that use this 2% of water, you realize it's a lot of water that has been used. So since South Africa's power generation is dominated by coal, a lot of water is used in the process. Hence, water is a critical resource in power generation process as it is required for cooling purposes of the plants. This exerts a heavy strain on the already water-scarce region of South Africa. The forecasted power generation capacity of coal-powered plants in South Africa in 2035 will be about 230 terawatts hour. The water required for cooling these coal-based stations will increase from over 300 gigaliters in 2013 to roughly 370 gigaliters in 2035. Eskom, the power utility, has been involved in conserving water because of the peculiar nature of scarce water resource in South Africa. And one of the methods Eskom does this is using the dry cooling system. The dry cooling technology does not rely on evaporative cooling for the functioning of the main cooling systems. And Eskom has been a technological leader in dry coal-fired power plants for more than 30 years. Eskom also uses desalination. Desalination is the process whereby wastewater from the mines are taken and treated and used for thermoelectric cooling process. The process mostly involves reverse osmosis, which is expensive. However, in recent studies, it is shown that desalination can be achieved using solar energy. Wastewater reuse. ESCOM also uses wastewater. It takes wastewater and processes it and then recycles it for cooling processes. Drought reduction. The power utility uses drought forecasting techniques to forecast drought, which also helps to minimize the amount of water that is used. ESCOM has also imbibed the use of clean coal technologies and underground coal gas. Clean coal technologies uses less coal with more thermally efficient systems to generate the same amount of power with an associated reduction in emissions. This has resulted in reducing the extent of flue gas cleaning required and helped to develop new methods of effectively cleaning the emissions in an affordable manner. ESCOM has also decommissioned old plants as a means of reducing inefficiency, because these old plants tend to be very expensive to operate and are very inefficient, and therefore they consume a lot of water. So in order to conserve water, as soon as the plants, the energy becomes more available, these old plants are being decommissioned. Also, better irrigation techniques have been used to improve water conservation. In terms of innovative technologies for thermoelectric power cooling, research has shown that there are many technologies that can be used. For instance, some studies report that non-thermal renewable energy has the lowest water consumption when compared to solar power and coal power stations, which has very high water consumption. Also, wet reticulating towers has the lowest cost per reduced water withdrawals on the average. Some studies have also shown the need to transform energy infrastructure to renewable or low carbon sources, thereby reducing water consumption by over 50%. Also, changing cooling techniques from open loop to closed loop in the south and from closed to air cooling in the north has improved water conservation in China. This shows that if we take the geographical location into consideration, different techniques can be applied based on what the geographical location provides. So that we don't have to apply a one-size-fits-all approach. So approaching water conservation in terms of the geographical location has helped to conserve more water in a country like China. Also, other studies have shown that moving from coal-generated power stations to natural gas has also helped to improve water conservation. This study was conducted in the USA, where coal-generated power station was converted to natural gas. Thus, moving from coal generation to natural gas resulted in significant reduction of water use in the USA. Also, harmonizing energy and water systems from both technical and policy perspective has also helped in reducing water consumption for power plant cooling. The study has the following recommendations. that all plants need to be decommissioned. This will significantly conserve a lot of water. Also, the use of renewable energy technologies needs to be upskilled. New technologies of water cooling need to be deployed. Also, the government of South Africa needs to enact new energy policies that are water friendly. In conclusion, the current status of water consumption for power generation is not sustainable. It is not likely that any cheap water conserving technologies will be preferred as a solution to efficiently using water. New power plants with renewable energy emphasis must be a priority for South Africa's electricity generation. Current power plants can make use of new water recycling technologies and clean coal technologies in order to conserve water. It is also seen that better irrigation techniques by farmers can free up much needed water for electricity generation. A strong collaboration between the research community, private and government sectors is also required for effective solution. Lastly, South Africa needs to be very proactive in terms of exploring a permanent solution which involves renewable energy sources. Thank you very much for your time. My contact details are displayed. Please feel free to email me any questions that you may have concerning the presentation. Thank you.